Dear children, today's topic is osmosis. Myself, Dr. Digna Varghese. In 1748, the French physicist Jean-Antoine Nollet, who filled a wine solution in an animal bladder, which he sealed it and kept it immersed in water, he found that water entered the bladder and causing to expand, and finally it burst. Such spontaneous flow of water to wine solution through animal membrane into solution is known as osmosis. Later, other scientists who studied this in detail, Dutroquet and Virot, they also called such process that flow of solvent molecules into solution, what they called osmosis. The osmosis term is derived from the Greek word that means push. Bladders used in such studies or bladders used for the process of osmosis, that generally called semi-permeable membrane. Semi-permeable membranes are those membranes which allows only the solvent molecules to pass through it. It means semi-permeable membrane, but not the solute particles. So, semi-permeable membranes are those membranes which pass solvent molecules to solution and not the solute particles. Okay. Semi-permeables are natural and artificial. Natural means they can be plant membranes or animal membrane. Some examples are egg's membrane and pig's bladder. Artificial membranes are copper ferrocyanide, calcium phosphate. Copper ferrocyanide or calcium phosphate in the walls of porous pods are nowadays extensively used. Now we are moving to the topic osmosis in detail. The phenomena of osmosis can be easily demonstrated by using this apparatus. Here you can see a thistle funnel is inverted, in which sugar solution is filled and which is kept in a water in a beaker. Okay. A thistle funnel is inverted here and in which sugar solution is partially filled, and this thistle funnel, the mouth of the thistle funnel is covered with the pig's bladder, which is kept in water in a beaker. After this, the level of the solution rises in the thistle funnel. This is by the water from the beaker entered into the solution through pig's bladder. This process is known as osmosis. The spontaneous flow of water to sugar solution through pig's bladder, that is known as osmosis. there here a pressure occurs, that means the level of the solution in the funnel gradually rises due to osmosis. This continues until the excess hydrostatic pressure developed in the solution is sufficient to stop osmosis. This excess pressure is equal to the osmotic pressure of the solution. So, osmosis is the net spontaneous flow of the solvent molecules through a semi-permeable membrane from the pure solvent into a solution, or from a less concentrated solution to a more concentrated solution, is called osmosis. The osmotic pressure of a solution at a given temperature is the minimum excess pressure that must be applied to the solution in order to prevent osmosis, or the entry of the solvent into it through a perfectly semi-permeable membrane separating the solution from the solvent. Okay, here you can see the membrane, and here solution, and here solvent. Osmosis is that from solvent to solution there is a flow, that is known as osmosis, but osmotic pressure is the excess pressure to prevent osmosis. Okay. There is another term that is known as reverse osmosis. Here you can see a picture or a diagram that representing or demonstrating the reverse osmosis. When a pressure is greater than osmotic pressure applies to the solution side. Here you can see this is solution side and this is fresh water, that is solvent side, and that is separated, solvent and solution separated by using a semi-permeable membrane here. So in the solution side we apply an excess pressure which is greater than the osmotic pressure. So a reverse process occurs, that is from solution side to pure solvent side there is a flow occurs, and here we take saline water here or any solution. Okay, if sugar solution is taken here for example, then solvent particles is water, solute particle is sugar, only solvent is passed from this part to this part. So fresh water will increase, okay, due to reverse osmosis process. The important application of the reverse osmosis is now being used for the desalination of seawater to get potable water. So, application of reverse osmosis, desalination of water. Desalination means process of removing saline impurities from water. Here you can see saline water is taken here, pressure applied, excess pressure applied, that solvent molecule is water. Water is passed from this solution side to freshwater side. So desalination occurs by this process. So seawater or brackish water is converted into drinkable water. So by this I conclude today's topic, osmosis and reverse osmosis. Thank you for hearing me.